Hi, this is Mrs. Slater, and today we're going to simplify complex rational expressions. The word complex means that there is going to be a fraction within a fraction. So you can see in the pre-algebra skills that we need to know that you have a fraction and then there's fractions in the denominator. So we're going to have to solve that by first looking at the denominator and evaluating what that is. And so if you get a common denominator of 4, the top's going to need a 2. So you're left with 1 over 5/4. So if you have a division sign and fractions, it would be 1 divided by 5/4. And you would leave the first one alone, change the sign to multiplication, and flip. So leave, change, flip. And 1 times anything is itself. So the answer to this is 4/5. Alright, so that's that. And here we have a fraction divided by a fraction, which is the same thing as this, 2/3 divided by 4/9. Leave the first one, change the sign, and flip the last one, and then cancel anything that you possibly can. And in this case, 2 goes into 4 2 times, 3 goes into 9 3 times, leaving us with an answer of 3/2. So we're going to have to use those skills in the following questions. The first step that you would always do is get a common denominator for every term. The second thing is we want to combine numerators. And then finally, we're going to leave, change, flip, which is what we practiced over here. Okay, so let's try the first example. And we want to get a common denominator. Now first, I want you to realize that there are 4 terms right here. Okay, the first term is x. The second one is the negative 1 over x. The third one, and then here's the fourth one. Okay, now if you look at every single one of these individually, they all have a denominator, but some of the left side does not need one. So really, it's just divided by 1. So now that we have all these denominators, so what I mean is the 1, the x, the 1, and the x, what is a common denominator for all of them? Well, they can all go into x, so that would be the least common denominator. Now let me get rid of those circles. And if they all need an x, that means this one, you multiply both top and bottom by x, and then the one right below it, same thing. Okay, and the reason that we can do that is, so now every single denominator is the same. So the top is x squared minus 1 all over x. The denominator is x minus 1 all over x. So this is what we did in previous lessons by itself. So you just have to take 2 of each and solve. Now we're going to leave, change, flip. And we have x squared minus 1 over x multiply by the reciprocal, x over x minus 1. So what ends up happening is the cross cancel will make those x's go away, and then you're left with x squared minus 1 over x minus 1, and we should always leave our answer in factor form. The top is difference of 2 squares, and the bottom is just x minus 1. Those are all products, so we can cancel it out for a final answer of x plus 1. I apologize for the lack of room. If you have some extra paper, that might be a good idea to work on an extra piece of paper on these. Okay, the second one is very similar to the first one, so I'd like you to try that one on your own. So the answer is 2a minus 3 over 5a plus 1. Alright, so now let's try the next one. Sorry about that. Okay, here again we have different terms. This case we have 3 terms. This is 1 over 1, and the other one, there's the second one, and here's the third one. And if you look at all the denominators, you have a 1, an x, and a y. So what is a value that all 3 of them will go into? And the answer is, the GCF would be x, y. So I want to change all of them so they have a value of x, y in the denominator. So the next part would be xy over xy. The denominator, it needs 1 over x, so that one would need a y. This one would be 1 over y, and so both of those need an x. Okay, so what ends up happening here is, I'm going to go in below here, you have xy over xy again, and then the bottom is going to be y plus x all over xy. When you do the process of leave, change, flip, the x and y's will end up canceling out, so let me show you that. Get a little more room here. So leave the first one alone, change the sign to multiplication, and flip the second fraction. And look at this. Those cross out, and it leaves you with xy over y plus x, all factored, so then you know you are finished. Okay, and then number 4, let's go ahead and try that one. Before I show you how to do this, I would like you to factor every single trinomial. So hopefully we have a match, and what you can do now is leave, change, flip. The first two would be like this, and then you change the sign and flip the denominator, and now all we have left is to cancel. That is a 2. Okay, so we can cancel diagonally or up and down. The y minus 2's are exactly the same, so are the y minus 7's. And all that is left, nope, I don't think there is anything left. So your final answer then is y minus 3, y plus 1, all over y plus 3, y plus 2. So in all the multiplication, they have to be exactly the same before you can cross them out. The next two are very similar, so we're going to do one together, and then I'm going to have you do one for class tomorrow. And again, how many terms? We have 4 terms, so I need to get every single one of them with a denominator. So what that means is 2 would be over 1. This is a negative exponent. Remember way back when we did negative exponents? That is now going to be underneath the 3. It's not attached to the 3, so the 3 is going to stay put. And then we have 1 over 1 plus 1 over x cubed. Again, that negative 3 is going to turn it into a fraction. Okay, so decide what the GCF is. Look at all the denominators. And x cubed is a number or a value that they will all go into. Okay, so I'm going to multiply the bottom by x cubed and the top. This one just needs an x. This one needs both, or all 3 x cubes, and the last one doesn't need any because it already has x cubed. So what that's going to look like is 2x cubed minus 3x all over x cubed. Then on the bottom we have x cubed plus 1 all over x cubed. Okay, so in this next spot, we're going to go ahead and leave, change, flip. Leave this one alone. Change the sign to multiplication and flip the next one. Okay, so again, what's nice about this is the x cubes are going to cancel, and then we always want to leave everything in factored form. So you have 2x cubed minus 3x all over x cubed minus 1. There is an x in common, so we should always take that out. And when you do take that out, 2x minus 3 remains. And then this right here is difference of cubes. So you should leave that in factored form as well. And because it is difference of cubes, I'm going to go ahead and have the same sign, opposite sign, and always positive. Take the cube root and the cube root, and then square the first term, multiply the 2 of them, and then square the last term. Nothing in common to cancel, so that's going to be your final answer. So in the next one, I want you to go ahead and solve and do the exact same steps and do practice this. Do not ignore it. Okay, so on the next examples, they're no different than before, just more practice problems. So again, you want to find a common denominator for all terms. You want to combine the numerators and then leave, change, flip. There you go. There's a fancy name for it. Okay, look at all of the denominators. You've got a y, a z, a y, and a z. So a value that they're all going to go into is yz. So multiply the first one by z. The second one's going to have to be multiplied by y. This one's going to have to be multiplied by z. And the last one's going to have to be y. So on the top, putting the numerators together, 2z plus 5y would all be over yz. And the bottom is going to be z minus 4y all over yz. Okay, so if you leave, change, flip, leave the first one alone, change the sign to multiplication, and flip the denominator, what ends up canceling leaves you with 2z plus 5y all over z minus 4y. There is nothing in common and there's no factoring, so I know that that's my final answer. Alright, the next one, we only have two terms here. And in these two terms, you have these two as our denominators. And it looks like the lower one only needs an a. So that's all we're going to have to do here is multiply by a and multiply it by an a. So what we are left with is a squared minus b squared over ab. And then the bottom one would be a squared plus ab all over ab. Okay, so let's go ahead and factor. Let me get rid of some of the other stuff here. If you factor the top, no, I'm sorry, no, we're going to leave, change, flip. A squared minus b squared over ab times, flip the second one, a squared plus ab. Okay, and then it's nice because these end up canceling out. So you are left with a squared minus b squared over a squared plus ab. And it does factor, so we are going to have to factor both of them. A minus b, a plus b, all over a in common, so a plus b would be left over. And since they're products, we have all these parentheses in there, we can wipe both of those out because they are exactly the same, leaving us with an answer of a minus b over a. Okay, now the third one looks a lot like one of the previous examples, so I'd like you to go ahead and do that one for class tomorrow. And then the last one, I'm just going to get you started, and then you can also finish with that as well. So if we need a common denominator, here we have everything over 1, and we are looking at all these denominators. What is the number all four of those are going to go into? Well, that's going to be 9x. So the first one you want to change into 9x over 9x. The next one, how are you going to get 9x is by multiplying by 3. So that would be 6 over 9x. And then the bottom, if we want that to be a 9x, we're going to have to multiply it by both top and bottom. So you get another 9x over 9x. And then the last one doesn't need anything. Okay, so take it from there, finish it, and we'll check it. I'll check tomorrow.